So, assignment AF1V, non-calculator. In all calculations, show clearly how you work out your answer. Answer all questions in the spaces provided. Number 1 says that 430 centimeters is equal to how many meters? So centimeters, convert it into meters. What do we know about centimeters and meters? 100 centimeters, you have to know this, is equal to 1 meter. So therefore, if we want to try and work out 430 centimeters, then we have to work out how many hundreds there are in 430. So it will be 430 divided by 100, which you move the point 2 places, you get 4.3 meters. So looking at the choices of answer, we see that this is the correct answer here. And we move on to number 2. Question 2. Which of these is the net for a tetrahedron? Circle the correct letter. So that's a tetrahedron, and you can see that it is made up of 4 triangle faces. Each face is an equilateral triangle, and if you look at any vertex, any corner or point, there are 1, 2, 3, well, first of all, we have 3 faces at each vertex. Now, if we look at the first, D, shape D, that cannot be right because it's got a square and we've got 4 triangular faces only. Number C must be wrong because there's only 3 triangles there and there should be 4. Part B, if we consider this point, vertex, we've got 1, 2, 3, 4 triangles meeting there. So we only want 3 faces at each vertex, so that must be wrong. So it must be A, but let's check why. 4 triangular faces, yes, 1, 2, 3, 4. 3 faces at each vertex, let's see. At this vertex, we have face 1, 2, 3, yeah? And at this vertex, we have faces 1, 2, 3, yes? And at this vertex, we have faces 1, 2, 3. So there's only one more vertex, which is when you fold up the 3 corners to come up to the out of the page, if you like, then this corresponds to the vertex here. Then you can see that once again there are 3 triangles. So A is the right answer. Move that out of the way. And if we move on to number 3, number 3 says circle the fraction that is equivalent to 3/5. So equivalent fractions. We know that we can get equivalent fractions by taking any fraction and multiplying the top and the bottom by the same number. Whatever number you multiply on the top, you multiply on the bottom, you'll get an equivalent fraction. So the lowest number you can choose in that block is 2. So 3 times 2 along the top means I have to have 5 by 2 on the bottom, which comes to 6/10. I've got 6 on the top, which is one of the answers there, or all the answers have got 6, and 10 on the bottom is that one, the third option. So that's one I circle there. Question 4. Simplify 3x minus brackets 2x plus 5. First thing to do is get rid of the brackets. 3x minus everything inside the brackets. So I'm subtracting 2x. And I'm also subtracting positive 5. So I'm subtracting 5. Now I can try to simplify this by collecting like terms. I've got 3x minus 2x. I can combine those together. and I get 1x, or x, and minus 5 is on its own because there's nothing else to go with that. So I'm left with x minus 5. I look at the options and I see that it's the first one there. Question 5. Complete the table from minutes to hours. So this question is all about minutes and hours. So you have to know that there's 60 minutes in 1 hour. So therefore 40 minutes, we'll just check their first example. 40 minutes is equivalent to 40 out of 60 if you want to change it into an hour. And 40 over 60, cancel by 10 and cancel by 2, you get 2 over 3 for the hours. So that's correct, 2/3. 45 minutes, we can do it in the same way. 45 divided by 60, I can cancel by 5 first of all, goes 9 over 12, but I can still cancel again by 3. 3 into 9 goes 3, and 3 into 12 goes 4. So I get 3/4 of an hour for 45 minutes. The last one is a bit the other way round. 1 1/4 hours, how many minutes? 1 hour, we know already, is 60 minutes. So then we're left with another 1/4 of an hour. Well, if 1 hour is 60, 1/4 of an hour is 1/4 of 60. So you divide by 4, 60 divided by 4 is 15 minutes. So 1 1/4 hours must be 60 plus 15. Which comes to 75 minutes. So that's question 5 finished. Moving on to number 6. Here are some numbers. Write the numbers in pairs so that the sum of the numbers in each pair is the same. So we've got to find 2 numbers, see what they add up to. Let's try the first 2, just see what they come to. 7.3 plus 10.7. So 7 plus 10 is 17.3, and 0.7 is another 1. That makes 18.0 altogether. So that's those 2. Now, what about if I start with 15.7? 15.7, it's no good adding 5, that's no good, that would make it 20. If I did 12, that would make it 27, it's too big. But 2, yes, 15.7 plus 2.3, we look at that. 15 plus 2 is 17, 0.7 and 0.3 is 1, so that's 18 again. And now we're left with the last pair. Let's check that they come to the same total. 5.7 plus 12.3. 5 plus 12 is 17, and another 1 makes 18. So we've got 3 pairs, each pair adds up to 18. I'll just write them in the answer spaces as we are told to. We move on to number 7. Question 7 says, this triangle is drawn accurately. So, which type of triangle is it? Tick 2 boxes. Equilateral, isosceles, scalene, obtuse angled, and right angle. You've got to know the meaning of all these words. So let's just revise. Equilateral. Equilateral triangle has 3 equal sides. Isosceles has 2 equal sides. Scalene, all sides are unequal. Obtuse angled, one angle should be an L there. one angle is bigger than 90 degrees, and right-angled, one angle is equal to 90 degrees. So we've got to decide which of these are true for this case. 3 equal sides, no, I've only got 2 there, so that's not the case. 2 equal sides, yes, definitely. Scaling, all sides unequal, no, because we've got 2 sides equal, we're told. Obtuse angled, one angle is bigger than 90. Now you are told that the angle is drawn accurately, and if you look at this, you can see that this angle is bigger than 90 degrees. So bigger than 90 degrees means obtuse angled. And right angled means one angle is equal to 90. No, there are no right angles in that triangle. So we've ticked the 2 correct options. Number 8, 31% of 200. That means 31 over 100 times 200. And we can cancel by 100, and we're left with 2 on the top. So 2 times 31 is 62. So that's our final answer there. And number 9 now says, write 180 centimeters as a fraction of 3 meters. Give your answer in its simplest form. Now we know 1 meter is equal to 100 centimeters. So 3 meters must be 300 centimeters. So 180 as a fraction of 300 centimeters is going to be 180 over 300. I can cancel by a 0, and I get 18 over 30. Now what goes into both of these? 3 goes into 18 and 3 goes into 30, but also 2 goes into that. 6 is 3, 2 into 10 is 5, so I've got 3/5 as my fraction in its lowest terms. Question 10. Here are some properties of numbers: odd, multiple of 3, prime, square, even. First thing I think to do is to write down the first few members of each of these sets. Odd, we know what odd numbers are: 1, 3, 5 and 7 and so on. Multiple of 3, your 3 times table: 3, 6, 9, 12, 15 and so on. Prime numbers, which have no other factors: 2, 3, 5, 7, 11. Square, 1 times 1, 2 times 2, 3 times 3, 4 times 4 and so on. Even, 2, 4, 6, 8, 10 and so on. Which 2 properties does the number 4 have? Where does 4 belong? It's in, yes, it's in D and E. Okay, square and even, so it's D and E. Next, can one number be prime and even? Give a reason for your answer. Prime and even is C and E, so looking at C, we've got those numbers: 2, 3, 5, 2, 4, 6, 8 in the second one, and then belongs in both sets. 2 is a prime number and 2 is an even number. So 2. So the answer is yes, 2 is prime and even. And the last part of number 10, can a number have all of the properties given? Give a reason for your answer. So can a number belong to all of these sets? I don't see one, and a good reason for that is A is odd numbers, E is even numbers, and you cannot have a number which is odd and even, because even means divided by 2, divisible by 2, and A means not divisible by 2. So no, because a number cannot be even and odd. Number 11. James, it's an unusual question. James has 6 coins in his pocket. If he picks 5 of the coins, the most he could pick is £5. And the least he could pick is £3.20. How much money does he have altogether? It's hard to think of a way to approach this question. I like to draw pictures if I'm stuck. So I think I'll start with the lowest value coin and go up to the highest. So I think I'll call the lowest one A. That's my lowest coin. And I'll call my highest one B. And then the other 4 in the middle, I don't know what they are. I'll just put 4 dashes there. So we're going from lowest to highest. They're all arranged in order. The most he could pick is £5 when he chooses 5. Well, he gets the most if he leaves out the lowest one. So I can leave out the lowest one, and I can say that those 5 without the lowest A comes to £5. Then the other sentence says that the least he could pick is £3.20, which is when he leaves out the high value coin B. So though that group, the lowest 5, adds up to £3.20. So looking at it like that, I wonder if you can see that if I have the highest group and I subtract the lowest group, that means that the B coin minus the A coin must equal the highest total, £5, minus the low total, £3.20, which comes to £1.80. So the difference of 2 coins is £1.80. Can you think of 2 coins which have a difference of £1.80? The only answer is if I have B to be a £2 coin and A to be a 20p coin. But we haven't answered the question yet. We go back to the question, how much money does he have altogether? Alright, so we know there's £5 for the top 5 coins, and that means you have to add on the coin A. So the money that he has is equal to £5 for the top 5 plus the value of A, which we know A now is 20p. So the amount of money he has is £5.20. Number 12, here are 3 expressions, p plus q, q minus p, p times q. When p is 3 and q is minus 4, which expression has the greatest value? You must show your working. Okay, so p plus q is 3 plus negative 4, and to work that out, you'd have to think of a number line where maybe we mark the point 0 somewhere on there. Then 3 means 3 steps to the right, followed by negative 4. So followed by 4 steps to the left. So that could be my negative 4 there. So 3 followed by negative 4 takes me to this point, which is 1 before 0, negative 1. Q minus P means that we have negative 4 minus P, it's minus 3. So 4 steps to the left followed by 3 steps to the left is 7 steps to the left That's straightforward. P times Q, that means it's 3 times -4. And whenever we have a positive times a negative, the answer is always negative, and 3 times 4 is 12. So we have three answers, -1, -7, and -12. So on a number line, to see which one has the greatest value, let's make another number line. And if we mark 0 somewhere, over there, then -1 means 1 step to the left of 0. -7 is 7 steps to the left, or 7 units to the left of 0. And -12 is 12 units to the left of 0. And we can see that the greatest means the one which is furthest to the right, which out of those three is -1. So -1, or as I should say, P plus Q. Number 13. The table shows the ratio of dog walkers to dogs. German Shepherd, 1 dog walker for 3 German Shepherds. Yorkshire Terriers, so they're small dogs, 1 dog walker can look after 6 dogs. A walker can only take 1 breed of dog. There are 6 walkers to take German Shepherd dogs walking. What is the greatest number of German Shepherd dogs that can go walking? Well, we know that 1 walker can look after 3 German Shepherd dogs. So if you have 6 walkers, 6 times as many, so we have 18. 6 times 3 is 18. So the answer will be 18 German Shepherd dogs. That would be quite a lot of German Shepherd dogs. Okay. Part B. One day the dog walkers need to take 5 German Shepherd dogs and 12 Yorkshire Terriers out at the same time. What is the smallest number of walkers needed? So we know that 3 German Shepherd dogs need 1 walker. So double that, 6 German Shepherd dogs would need 2 walkers. So 5, if I have 5 German Shepherd dogs, I can't manage with 1 walker, I've got to have 2 walkers, even though they're not completely busy. And the 12 Yorkshire Terriers, I know that from the table, let's just check. 6 Yorkshire Terriers can go with 1 walker. Right? So 6 Yorkshire Terriers for 1 walker. So double that, 12 Yorkshire Terriers go with 2 walkers. So my 12 Yorkshire Terriers I want to take need 2 walkers. So I need 2 walkers for the German Shepherds and 2 for the Terriers, so 4 altogether. Number 14, a card T in the shape of a trapezium has an equilateral triangle added to form shape W. So T is changed into W. Which one of these statements is true? Tick a box. So let's just draw that equilateral triangle which is added on. There it is. It says the area of T is more than the area of W. So if I shaded area of T like this, then that would still appear the same over here. But in addition, we've also got this little triangle here. I'll shade that the other way. So T is definitely not less than the area of W, but the second statement, the area of T is less than the area of W, that is correct. W is bigger, T is less. So T is less, and they are not equal. And it's not true that it's not possible, so the answer is the second statement. Number 15. The edge of a rectangular field 40 meters long and 30 meters wide is to be fenced using wire and posts. Posts have to be placed in the ground every 10 meters. What length of wire is needed? So I think maybe I'll start by drawing a rectangle for the field. And now what do we know? It's 40 meters long and it's 30 meters wide. It's a rectangle, so it's the same on the opposite sides. So that's my total length of wire, 30. I'll start with 40, 40 plus 40 plus 30 plus 30. Add those all together and we get 140 meters. Part B, how many posts are needed? So read there, it says a post has to be placed in the ground every 10 meters. So let's start with a corner post, then count 10 meters. So there's another post, another 20 meters, 30, 40. Same on the opposite side, the other 40 has 10, 20, 30, 40, like that. Along the 30 side you have 10, 20, and the 30 one is already there from the other side. 10 and 20 there. Okay. How many posts are needed? Just count them all up, all the way around. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 posts which are needed.